Hello dear students, welcome back to a YouTube class. So in the previous class we had seen about the traversing a linear array, how we can do the traversing. We had seen the algorithm and we had also seen the program for traversing the elements into your array. So I'll write algorithm of a same traversing. We'll see it one more time, a short revision, then we'll move to the next point, that is the next algorithm. So the traversing can be done in 3 steps. The step 1, we have to take first for loop, location is equals to LB to UB, you have to initialize, then you have to process it, that is array location, and then you have to stop the for loop, that is end of for loop we say, and then the exit. So this processing is your step 2 and exit is step 3. Exit is step 3. So what we are doing here, we are taking a loop. In the loop, the counter we have taken as the location, which will tell you the position of your array element, that is the I counter. So here we have taken it as the location. First, it is always starting with the first element, that is with the position LB we do it, that is the lower bound, and it go on doing the processing till it reaches your UB. UB means upper bound, the last element. Processing is accessing each element, that is the array name will be A, you can take it. Location is each value as we change the I in counter value, like that the location value is changed. Do it till the condition is true. Once the condition gets false, you have to come out of that loop, so we say end of for loop. And your processing is done means you have to come out of that part, that we say as exit. Done? So this is the algorithm which you have to remember for traversing an element into your array. The algorithm can be asked for 3 marks. We had written the program also, that is the reading part and writing part of your elements, input and output, the array elements. Then, so the program we had seen, I'll just write the part of input and output, you remember, because already the program we are written in PUC first year also, and I explained in the last session also. Then, so I'll write only the statements. Input is done for I equals to 0, I less than n, I plus plus, C in A of I, C in A of I, and then the output is done with the same method for I equals to 0, I less than n, I plus plus, C out, set W we write to give the position or some space between each element, A of I value. Done? So these are the lines. This is for your input, this is for your output, which you have to write into your program by adding your header files. Done? So this is how we do the traversing function. Next we'll learn the next operation on your array elements. We'll write the program and we'll write the algorithm also, that is insertion of an element. Insertion of an element or inserting an element into an array. So let me write the heading, insertion an element or inserting an element into an array. So inserting an element into an array means adding the elements into an array. So insertion refers for inserting or adding an element into your array. Okay. So the new element can be added into your array, but the thing is your array size should be enough to accept the new element. So when you want to add any extra element into your array, you can add it from anywhere. Maybe at the start, maybe in the middle, or maybe at the end, provided your array should be the larger or should be have the size empty space so that we can add the extra new elements. That adjustment should be there in your existing array. If your array has the size so that we can add the extra new element into your array, then the insertion will be done successfully. The insertion will be done successfully. Then, so when the insertion comes, adding the new element can be done at the beginning, at the end, or at any given position of your array. Then, so when you are entering or inserting an element into particular position, then what you have to do is all the elements from that asked position, those should be shifted to the next higher order position. What you have to do is a small adjustment. When you want to add an element into a given position, then the element from that position, what all the elements we have, those all should be shifted to the next level, so that that position will become the emptier and we can add that element into that position. Then, so first I'll give you the example. First we'll understand how this insertion will happen. Then we'll write the algorithm and program on this. Okay. So just consider that there is an array. Consider that there is an array called as X. Array called as X with the size 5. With the size 5. Done. Now the elements we have already added into this is 11, 22, 44, 55 and 66. We had added some elements into this array, that is 11, 22, 44, 55 and 66, which are stored in consecutive locations. Okay. Suppose, now what we want to do is, we want to add 33. We want to add 33, and where we want to add? We want to add it in the position 2. We want to add it in the position 2. That means this is the 0th position, this is the first position, and this is the second position. Now we want to add this 33 into this second position. Why it is second position? Because subscript always starts for your array from 0. 0, 1, 2, 3, 4. Like this it will be there. So here in the second position we want to add 33. Okay. Now what we have to do is, the other elements which are there, the 44, 55 and 66, we have to shift to the next level so that this place will be empty and we can add 33 here. So what you have to do is, first you have to move number 66 to the position 5. Here in the 5 position you have to move 66. Next you have to move number 55 to the position 4. When you shift 66, 4 will be empty, so easily you can bring 55 here at the 4th position. Next we have to move number 44 to the position 3. To the position 3. Done? Now position 2 will be empty because we have shifted. No, 66 has been added into 5, 55 has been added to 4, 44 has been added to 3. Done? Now the position 2 is blank and we can add that 30 to the position 2, that is in A of X of 2 position, into your X of 2 position. So what we can do is, now position 2 is empty insert 33 into the position 2, that is x of 2 is equals to 33 now. X of 2 is equals to 33. Done? Like this we have to do it. I'll show it with a pictorial representation that will be easier to understand for you all. Done? So let me take first array. So this is x of 0th position. What is stored here? 11 is stored. X of 1 position, 22 is stored. X of 2th position, 44 is stored. X of 3rd position, 55 is stored. X of 4th position, 66 is stored. X of 5th position is empty. Fine. Now, very first step what you have to do is move 66 to the position 5. This 66 we have to move here. So, x of 0 is as it is, x of 1, x of 2, x of 3, x of 4, x of 5. 11, 22, then comes is your 44, 55. What we are doing? We are inserting or we are shifting this 66 to the 5th position. We are shifting this 66 to the 6th position. So what it done? Here 66 will be shifted. Here 66 will be shifted. Then what will happen? It will be shifted and your next x of 4 is empty now. So in x of 5th position, the 66 is shifted. So 66 came here. This is empty now. The others will be remaining as it is. Here x of 0, 11 is there. In x of 1, 22 is there. In x of 2, 44 is there. In x of 3, 55 is there. Fine. Next. Move number 55 to the position 4. So what we have to do is now we have to move this 55 here so that this place can be empty. What we have to do is in x of 5, 66 is there. Okay. In x of 4, we have to bring this 55 here. So in x of 4, 55 will come. X of 3 will be empty as it is. X of 2 contains 44. X of 1 contains 22. And x of 0 contains 11. Fine. Now next what we have to do? Move 44 to the position 3. You have to bring this 44 which is there in x of 2. You have to bring it here in this position. So it will be empty. Done. So the next step. X of 5 contains 66. X of 4 contains 55. X of 3. What we are doing? We are bringing this 44 which is there in your x of 2 into x of 3 position. Done? So you have to bring here. So it will come here. Now x of 2 is empty. X of 1 contains 22. And x of 0 contains 11. X of 0 contains 11. Done. Now these all elements has been shifted. Now x of 2 is empty. What we have to do? In second position we are inserting 33. Now add 33 here. Add 33 here. So your new array after adding a new element will get it as 11, 22, 33, 44, 55 and 66. It is there in the 0th position, 1 position, 2nd position, 3rd position, 4th position and the 5th position. So in this way your insertion works. What you have to do is when all you want to add your any new element into your array, what you have to do is from where in which position you want to add, that position you have to note it down, and the other elements which all are there, those you have to shift it to the next higher level. Means 66 we have to shift it to the 5th position, 55 to the fourth position, then 44 to the third position, so that the second position will be empty because we want to add 33 into second position. So in that position we added 33 now. Done? So you have to concentrate always that when all you want to insert any element into your position, given particular position, then all the elements from that asked position, you have to shift it into your higher order position. To the next level you have to go on shifting. Done? So in this way we have to do your insertion. So this was the normal example I had given you, an idea how actually it works in the background. So we'll write first the algorithm for this, then I'll write the program. The algorithm can be asked for 5 marks or 3 marks, and the program is there for your lab. Done? So first I'll write the algorithm and then I'll explain it. Then we'll see the program and we'll trace it. No any issues. Done? So the algorithms. To insert an element. Algorithm, what you have to do is algorithm to insert an element. So what all the elements I am using in the algorithm, I'll tell you in one line. Okay. So here I am considering an array with the name A. Is an array. A is an array with n elements. Means in this n we are taking to add the elements. N will define these many numbers or these many elements are there in your array. Then next, one more variable we are using in this algorithm, that is called as item. That is called as item. It is an element which we want to store or which we want to add into your array. Means extra element we want to add. No, here we are directly denoted with the number as 33. We want to add it extra, but in algorithms we don't take numbers, we have to take the variables. Then so this 33 or any variable which you want to add it, that will be stored in item, that will be stored in your item. Done? So item is the element to be inserted in the position. So you have to read one position where you want to add it. So that position will be P. That position will be P. Understand what all the variables we are using in the algorithm. Here we are using an array called as A. How many elements are there? N elements. One extra element we want to add, that will be considered as item, and where we want to add, in which position, that is there in the P. So don't get confused. X means A. How many elements are there? Here you can count it like 5. So that 5 will be stored here in N. Which element you want to add extra? 33, that is stored in the item. Where, in which position you want to add? In second position. So that is stored somewhere, that is in the P. Done? So A is an array name. N is the number of the elements. Item is stored with a new element which you want to store, add it into your array, and P is the position where you want to add that item. Done? So these are all the variables we are using. Now I'll write your algorithm. Note it down. Done? So first I'll write the algorithm, then I'll explain you. Step 1. The first step 1. For I equals to n minus 1 down to P, A of I plus 1 is equals to A of I. Next, end of for, or end of for we can write it, no any issues. Next, step 2. A of P is equals to item. Step 3. N is equals to n plus 1. And step 4. Exit. Step 4. Exit. So again we have 4 steps. What all the 4 steps we have? Step 1 is first for loop. I had not taken location here. We have started to use I counter because you can remember here I means your counter values. Then, so for I equals to n minus 1 to down to p means what we are doing, as we have to shift the elements to the higher next level means we are coming at the down. So what we have to do is loop should be in reverse. The loop should be in reverse. So what we are doing, we are shifting these elements to the next element till we reach the position. See here, I want to add this 33 to the second position. So what I did, from second position, what all the elements are there, those all the elements are shifted to the next level so that I can make this second position empty and we can add this 33 in the second position. Done. So what we did, 66 which were there in the fourth position, we shifted to fifth position. 55 we shifted to fourth position. Then 44 we shifted to third position. Then second position was empty, so we we added this 33 into your second position. Then, so it was in reverse, it is going 4 to 5, 3 to 4, 2 to 3, like that. Then, for that we have to write a loop in reverse. We have to write your loop in reverse, that is I equals to n minus 1 down in reverse till your position. What you have to do is, you have to initialize the value which is there in your A of position into your A of I plus 1 position. So in A of I, in x of 4, 66 was there. So x of 4 plus 1, 5th position, you have to bring this here. Then, so what we are doing, which is there in your x of 4, we are bring it into x of I, means 4 plus 1. Then, so I is here 4 and 5 means I plus 1. Then, so what we are doing, fourth position, what value is there, that we are putting into fifth position. Next from third to fourth, from second to third, like this we are shifting. So we had written the loop I equals to n minus 1 down to p, and what you have to do is each time what is there in your A of ith position, you have to store it into A of I plus 1. Once you are done till you reach P, you should not shift everything. Till the given position, you have to do this process. Once this process is done, then you have to come out of the loop. That is end of for. That is end of for. Next, step 2 says that which element you want to add it. That element value, you have to add it into A of position. For example, here, in second position means in x of 2, what we want to add? 33. So here item is nothing but 33, p is nothing but 2. So in x of p means x of 2 is equals to item means 33. Then, so here the item is added into your x of p, that is A of p value. Then next what you have to say, n is equals to n plus 1, because here earlier only 5 elements were there. When we add this 33, the array has been increased. Now it has become 6 elements. So earlier n was there with the 5 elements. Now n has become 6. So you have to make n is equals to n plus 1. You have to make n is equals to n plus 1. So that last step we had written as n is equals to n plus 1. Then you have to exit from that. Clear? What we did here, the same we had written in the algorithm. Try to understand. A in place of x, A array we had taken. How many elements you are adding into your array, that is will be there in your n. Which element you want to add, that is the 33 will become your item. Where you want to add in second position, that will be your p. Done. So what we have to do is, when all you want to add any element, from that position which all the elements are there, those all you have to move to the next higher position. For that we had written the loop for I equals to n minus 1. From the last we have to always shift, no? So from last we had starting I equals to n minus 1 down to till where you want to do, till the position. So here position was second, so 44, 55, 66, everything we shifted. So 66 we shifted to 5, 55 we shifted to fourth position, and 44 we shifted to third position, so that this second position was getting empty. So you have to do it every time, this process, and once you are done with this, you have to stop the loop. Then what do you do? Your given position will be empty after this process. In that position, which element you want to add, that you have to add it. So what we did here this position got empty, so 33 we had added in the second position. Done. So now see, earlier the elements are 5, so n size was 5. Now when we add the extra element, n becomes 6. Okay, so n was 5, now n becomes 6. So we have to instruct the array, you have to make n is equals to n plus 1. You have to make n is equals to n plus 1. Then you have to come out of the loop, that is the exit. So this is the algorithm for inserting an element or to add an element into your array, which can be asked for 5 marks, which can be asked for 5 marks, or which can be asked for 3 marks also. So for what we got the algorithm, based on that the marks will be varies. Remember, it is very easy. Just remember the concept, how it works. If you remember this concept, how it works, then easily you can remember on this. Then in reverse, we have to shift each element from the higher position to the next position. Next we have to add the element which you want to add it in the given position. Then increment the array size because one extra element has been added, and then you have to exit it. So remember this algorithm, then we'll see the program. So now we'll write the program for this, which is there in your lab. So first add it to your header files. The question is to insert an element into your array. To insert an element into an array. Okay, so the program what we are writing now is simple, using your procedural oriented. Later at the end I'll tell you how to do it using your classes and object, because in a lab we have the same program using classes and object, not using your procedural oriented. Done. So write down your header files. Hash include iostream.h, then hash include conio.h, and then the hash include iomanip.h. Next, main function, void main. Open the body of your main function. What all the variables you want to use in the program, those should be declared first. Then we have to start with the actual coding. So all are integer. So I'll take int a array name with the size 10. Then I need a counter I. I need n to know how many elements we want to add it. Then one extra element we want, that I'll store in ELE element. And where we want to add it, that position we have to read, so I'll take it as P, position. Done. So these many variables we need it right now. If anything is needed extra, I'll add it later. Done. So first is array A of with the size 10, A of 10. I is a counter, n is the size of your array, ELE is an extra element which we want to add, and P is in which position we want to add the ELE. Now next is clear screen. Clear screen with the previous output. Next we'll start accepting the values, that is input from the user. Very first thing, we have to take the size of the array. For that we have to print cout how many elements. Cout how many elements. So that will be stored in n. So C in n. C in n. Next, once you get the value of n, we start accepting the array elements. For that we have to print again one more message. Cout, enter the elements. Cout, enter the elements. For that we need loop. So for I equals to 0, I less than n, I plus plus, C in A of I. C in A of I. So we had taken the size of the array and we had added all the array elements into the array. Now we have to read the value, which element, extra element we want to add it in the array and in which position we want to add it. So these two elements we have to read, that is the value of ELE and the value of P. So for that we'll print a message, cout enter the element to be inserted. Cin, that will be stored in ELE. Cin, that will be stored in ELE. Next, in which position we want to add it? In which position we want to add it? That position we have to read and we have to store in the P. So we'll write a message, cout enter the position. And remember, the position should be in the positive number. Fine. So we'll write here 0 to n for a reference. Cin P value. Done. So reading is done. What all we have to read? The value of n, that is how many elements we want to add it. Then the elements into your array. Then which extra element you want to add it in your array and where you want to add it. So that is stored in P, ELE, A of I and n. Now we start adding the elements. The very first thing is what position has been entered by the user. We have to check it. This position what you had entered, it should not be greater than the n value. It should not be greater than the n value. If suppose your n value is 5 and you want to insert this ELE into 10th position, that is not possible because the array size is only 5 and you want to add it in the 10th position. That is an invalid error, you will get it. Done. For that reason, we have to check it first what P value we are adding. So if, we'll write that, if P is greater than n, if P is greater than n, then we'll print one error message, cout invalid position. Invalid position. The value, that is the position what we are entering, P value should be from 0 to till n. Should be from 0 to till n. Anything you can add it, but it should not be less than 0, that is in negative, because we know that the size of the array will never be in negative, and it should not be more than n. Then once your P value gets corrected, means it is between 0 to n, then we can add the value, that is ELE. For that we have to write else. So else we have to take the loop. Now we know that when all we want to add any extra element, what we have to do is from that given position, what all the elements all should be shifted to the next higher position, to the next higher position. For that the loop will come like for I equals to n minus 1 in reverse, because always from the last element it will be shifted. So for I equals to n minus 1, I greater than or equals to P, I minus minus. And what you have to do in this looping, A of I plus 1 is equals to A of I, you have to say. And then the next, once you are done with the shifting, then in A of Pth position we have to store the ELE value. We have to store the ELE value and increment the n size, that is the array size, by saying n is equals to n plus 1. N is equals to n plus 1. Done. So what all we are doing here, for in reverse each element of your array till the position, we are shifting to the next level, that is we want to add this 33 in second position. So from second position what all the elements are there, this 44, 55 and 66, we have to shift to the next level one after the other, so that this position will be empty and we can add this 33 here. For that we have to go from here, means first we are shifting 66, then 55, then 44. For that reason the loop is from in reverse, I equals to n minus 1, and till where? Till the position, till you reach the position. For that reason the condition is I greater than equals to P, and then it is in reverse, so always it is decrementing, not the incrementing, that is I minus minus. Then what we are doing, we are shifting the value a of I value into a of I plus 1 position. Done. So which was there in a of 4, it is there in, sorry, which was there in x of 4, it is there in x of 5. Next, which is there in x of 3, that is added in x of 4. Like that, which is there in each element, which is there in your a of ith position, we have to shift it to a of I plus 1. So once the shifting is done, the required position will be empty. Then what you have to do in that required position, what you had taken in ELE, that value you have to store here. And once your adding is done, if you concentrate, earlier values were only 5, now the values has been extra added, so the elements become 6. So you have to increment the value of n. So we say n is equals to n plus 1. Done. So this is how we add. After adding, we can display the array elements. The new array after adding, that we can display. So your array element will be like Cout the array after inserting an extra element is, and I'll take for I equals to 0, I less than n, I plus plus, Cout set w 4 and a of 5. Close your else and then write your get ch and then close your main function. Now just see, if you will not increment n value, that is n equals to n plus 1, if you will not write, then what it will do when you are printing this, that is after adding the extra element, if you want to print, then you write I equals to 0, I less than n, I plus plus. And n element what you have taken here, no, only those values will be added. Means the last ending one value which is added there at the end, no, that will not be printed. Fine. For that reason you have to compulsorily increment this value. Done. Now I'll show you how it will be executed. So first we'll see the output. Execute. What is the first message will be taken in the memory? These all the location will be stored. Then it will print how many elements you want. How many elements this message will be printed. So you have to add one value that will be stored in n. So add it as 5. Now n value is 5. Done. Next, enter the elements. It will print one more message. Enter the elements. Now we have to add the elements. We'll add 11, 22, 44, 55, 66. I'll take the same array. Fine. Next, enter the element to be inserted. What element we want to add, that we have to add it. Enter the element to be inserted. So which element we want to add? 33. Next, enter the position where you want to add it. Enter the position 0 to n. Now concentrate. If you enter the p value till n 0 to 5, then it will be successfully added, else it will print one error message. What error message? Here we had printed no invalid position. This error message will be printed. Done. So we'll add here p position as 2. Fine. So next it will come here now. It will check whether what value had entered to p is greater than n or not. So p value is 2. This is p value, this is ELE value, these all are a of 5 array elements. Done. So p value is 2. Is 2 is greater than, what is the n value? 5. Is 2 is greater than 5? True. Now it will come here. It will not go here. Okay. Sorry. Is 2 is greater than 5? No, it is false. So it will come here. If it is true, it will print a message invalid position. Done. So it is false. So it will come here. For I equals to n minus 1, I greater than equals to p, I minus minus. Means like this what we did here. Every time till your I value is there, your value are going to be shifted to the next, and you will get a of 2 value, that is x of 2 is empty, and then we say ELE is equals to a of p. What is there in your ELE? 33 is there. Here we add 33. And now earlier n was till 5, extra has been added, so we have to make n equals to 6. If we will not make n is equals to 6, means only 11, 22, 33, 44 and 55. Till here only the values will be printed, 66 will not be printed. For that reason, you have to add this statement n is equals to n plus 1. After this, the array after inserting an extra element message will be printed. The array after inserting an extra element, this message will be printed, and your array elements will be printed like 11, 22, 33, 44, 55. If you will not write this n equals to n plus 1, only these values will be printed. 66 will be skipped. If you write n equals to n plus 1, then the 66 will also be taken. Then like this your program works. Done. So in the today's class I told you how your insertion will be worked. We had seen the algorithms and even we had written the program also. So sit calmly, read it down, concentrate, try to solve, and then you will be easy to understand your algorithms and to write your program. If you have any difficulties relating to these points, note it down. We'll solve all your difficulties into your live class. The other algorithms and the programs we'll see in the next class. Thank you.